Hey science enthusiasts! Today we're diving deep into one of the most fascinating concepts in physics. Wormholes. You might know them from sci-fi movies, but the science behind them is even more mind-blowing than fiction. Imagine folding a piece of paper and punching a hole through both layers. That's basically what a wormhole does with space-time. It creates a shortcut through the universe. Pretty cool, right? But let's get into the real science behind it. Back in 1935, Albert Einstein and Nathan Rosen proposed something called the Einstein-Rosen bridge, which was the first mathematical description of what we now call a wormhole. The math showed that these bridges could theoretically connect to different points in spacetime, like a cosmic tunnel. The Einstein field equations, which describe how spacetime curves around matter and energy, actually allow for these bizarre structures. The mathematical formula looks something like this: R1/2 RG equals 8 pi GT mu nu per c. Don't worry if that looks like alphabet soup. The important thing is that these equations don't rule out wormholes as impossible. But here's where it gets really interesting. Theoretically, wormholes could not only connect different points in space, but also different points in time. Imagine stepping through a portal in 2023 and emerging in 1923. That's what we're talking about here. The math checks out, but there's a catch. The problem is stability. Natural wormholes, if they exist, would collapse instantly, too fast for anything to pass through them. To keep a wormhole open, we'd need something called exotic matter, with negative energy density. It's like anti-gravity material that pushes spacetime apart instead of pulling it together. Some scientists like Kip Thorne have proposed that advanced civilizations might be able to create artificial wormholes using exotic matter. They'd need to manipulate spacetime at the quantum level, which is way beyond our current technology, but not necessarily impossible. Here's a mind-bending thought. If we ever do create stable wormholes, we might need to be careful about creating time paradoxes. Like going back in time and preventing your own birth. Some physicists suggest that nature might have a chronology protection mechanism that prevents such paradoxes from occurring. The math behind wormholes connects to other fascinating physics concepts like quantum entanglement. Some researchers suggest that wormholes might be the geometric representation of quantum entanglement, two seemingly separate things that are fundamentally connected. What's really amazing is how close science fiction and reality can be. When Einstein and Rosen first proposed their bridge theory, it seemed like pure mathematics. Now, we're actually discussing how we might engineer wormholes in the future. The line between science fiction and science fact is often just a matter of time and understanding. Recent research has even suggested that wormholes might be more common than we thought. Some scientists propose that microscopic wormholes might exist at the quantum level, popping in and out of existence as part of the quantum foam that makes up the fabric of spacetime. The implications of wormhole technology, if we ever develop it, would be revolutionary. Imagine being able to explore distant galaxies without spending generations traveling through space, or studying the early universe firsthand instead of just observing its ancient light. But even if we never manage to create traversable wormholes, studying them helps us understand the fundamental nature of space, time, and gravity. Every equation we solve, every theory we develop brings us closer to understanding how our universe really works. The beauty of science is that it starts with what if and ends with here, SY. Wormholes began as a mathematical curiosity and have become a serious field of study in theoretical physics. Who knows? Maybe someday we'll look back at our current understanding of wormholes the same way. We now look at early theories about electricity or atomic structure. Remember, every major scientific breakthrough started with someone asking questions that seemed impossible to answer at the time. Whether wormholes turn out to be practical transportation devices or remain theoretical constructs, they're pushing the boundaries of our understanding of the universe. If you've enjoyed this journey through space-time, don't forget to hit that like button and subscribe for more mind-bending science content. Share your thoughts in the comments below. What would you do if you could travel through a wormhole? Keep questioning, keep exploring, and keep pushing the boundaries of what's possible.